Unified B, Lesson 2, continuing our discussion of circles. In this lesson, we're going to focus on points located on a given circle. So for the first example, we have a circle centered at the origin that passes through the point -5, 12. A point 11, y lies on the circle. We want to solve for y. So since we know the center is located at the origin, if we were trying to write the equation of the circle, we know that we have x squared plus y squared equal to the radius squared. Now we need to use this other point to solve for r. So if we're centered at the origin and we have a point -5, 12 that is on the circle, if we find the distance between these points, that's going to represent the radius. So essentially, we can think of this as a right triangle. We have our x distance and our y distance. So if we use the Pythagorean theorem, we can find the distance between these 2 points. So we're taking -5 squared plus 12 squared equal to r squared. Normally, if we're using the Pythagorean theorem talking about a distance, we're only going to use the absolute value, so we would use 5 instead of -5, but since we're squaring this quantity, it does not matter. -5 squared is 25, plus 12 squared is 144, equal to r squared. 25 plus 144 is 169. If we take the square root of that, we get the radius to be 13. So the equation for this circle would be x squared plus y squared equal to 13 squared. Now that we have the equation for our circle, we want to determine the y value that is going to complete this point if we know that the x value is 11. So we're going to substitute this x value of 11 back into our equation. So we get 11 squared plus y squared equal to 13 squared. Now we just have to simplify to isolate y squared by itself. So we would get y squared equal to 13 squared is 169 minus 11 squared, which is 121, leaving us with y squared equal to 169 minus 121 is not 100, it would just be 48. Last step, take the square root. So we get y is equal to plus or minus radical 48. Which, if we're looking for factors that are perfect squares, we can simplify this down into plus or minus. 48 is the same as 16 times 3. Square root of 16 is 4 times radical 3. So there's actually 2 different values for y that, if we plugged in to this original point, would satisfy and be a point on the circle. The next example we're going to go through is something we've talked about previously a little bit. So we want to prove or disprove whether the point lies on the given circle. So we have the center and radius for the circle. We want to determine whether the point 3.4, 1.2 is a point on this given circle. So the first thing we need to do is use the center and the radius to write the equation for this circle. The equation we get is x minus 1 quantity squared plus y plus 2 quantity squared equal to 4 squared. Now that we have our equation, we're going to take this point, 3.4, 1.2, substitute 3.4 in for x, substitute 1.2 in for y, simplify to see if the left side of our equation is going to equal the right side. So after we substitute those values in, 3.4 minus 1 would be 2.4. If we square that, we get 5.76. 1.2 plus 2, we get 3.2. If we square that, we get 10.24, and then equal to 4 squared, which is 16. 5.76 plus 10.24 is equal to 16. So we end up with 16 equal to 16, a true statement. So that means that this point, 3.4, 1.2, does lie on the given circle. Okay, if we got a number equal to a different number, something that was not a true statement, then that point would not lie on the given circle.